Let's start. So now the first question is when to use Hive or when to not use actually. So Hive will basically suffice most of your use case. Most of your use case in that in sense, you have data on HDFS. You have a big data. You don't want to write map reduce code directly because you don't want to go into the hassle of writing mappers, reducers, and then set the configuration for splitters, shufflers, combiners. You don't want all of that. Again, then you will also use Hive. And you have a structured or semi-structured data, still you can go with Hive. These are the situations when you would go with Hive. But the question is when to not use Hive. So for that, simple core key aspect to it is if your data is relational, if it is highly relational data, go with a traditional RDBMS system, don't go with a big data tool. Even if your data is, you're dealing with big data in RDBMS, try to suffice your requirement with serverless RDBMS system or apply traditional RDBMS optimization technique before switching to big data ecosystem, something like Hadoop or Spark. That is one use case when you don't have to use Hive. Next use case is when you need response in seconds. That is for your transactional processing. Do not use Hive if you have a transactional system. Hive or a Hadoop cannot replace your transactional system. Traditional Hadoop I'm talking about. I'm not right now talking about an HDFS layer, which has Apache Spark as a processing engine, and on top of that, Delta Lake for ACID compliance. I'm not talking about this system. I'm talking about traditional Hadoop ecosystem, where you have HDFS and let's say a Hadoop ecosystem tool like Hive, or you might be using MapReduce. In such a system, do not use, don't go with Hive for transactional processing. That's your second thing. Third thing, if creating schema for your file is difficult, that is if you have unstructured data. If you remember in the point one, I mentioned RDBMS, I mentioned when to use Hive is semi-structured or structured. But if you have an unstructured system, or if you have unstructured data, do not go with Hive. Hive won't be able to support your use case. Go with traditional MapReduce job, write a MapReduce job in Java. That would be much better as compared to writing a Hive query and creating a system in Hive. Then if your data does not exceed GBs, that's obvious. If you do not have a big data usage, then why would you use Hive? There is no need of using Hive itself. So that's that. Now let's do a quick knowledge check. Was it possible negative scenarios in MapReduce architecture? Who would like to answer that?
Wastage of resources, like storage, I mean to say.
Wastage of storage.
Yeah, like architecture, I'm not sure, but you showed one diagram wherein the block size was one.
Understood. Yeah, correct. That is basically complying with this point. If your data is not big data and you are using Hadoop for that, certainly MapReduce is not required. Correct. Yeah. Someone else was saying something.
If our input split is not optimized, then that will be the negative scenario. Like we are using 32 MB blocks or these kind of blocks.
Correct.
So using
let's say if you increase your block size by too much, let's say you keep your block size as 1 GB, then you won't be able to do the distributed processing.
Correct.
So, yeah, totally. It's a negative scenario. So you need to set up a block size or your input splits accordingly. Perfectly fine. Any other negative scenario that comes to your mind? How about shuffler and combiners being there by default, even if we don't use it? We don't have any requirement, but they are still going to be there by default for a few of the operations. I'm talking about traditional MapReduce job, not the Hive one. That will actually still be able to use it. But yeah, that's another use case. Where in MapReduce job, you do not need a shuffler and combiner, but they're still going to be there. They're still going to be there unless until you set it to off. So that's another negative scenario. Moving on, will the intermediate output be deleted after preparing the final output? Okay, who would like to answer this? This intermediate output is basically the output created by mappers. So by default,
Yes, it will be deleted.
yes, deleted. I mean, it will be deleted, but you have to delete. I mean, you have to mention in the code that it gets deleted. It is something like if you have written a Java program, you do garbage collection, right? So, and you invoke a program or you invoke a function to do the garbage collection. Similarly, in MapReduce, what you need to do is you need to delete the files if you do not need them afterwards. Otherwise, those files are going to be there. So answer is yes and no both. If you don't delete it, they won't be. But if you invoke a function for garbage collection and you delete them, it will be deleted. By default, also, it will be deleted. Just an FYI. If you have written a program that we were discussing, right? In that there is no garbage collection, but by default, what it does is it takes care of the mapper's output once it has been fed to reducer. So what are the different phases in a MapReduce program? Yes, this is an important one. Who can tell? Yes, Rupesh, go ahead. If you're saying something, I'm not able to hear you. I'm not sure what's wrong. Okay, let me just revise this for you. So first phase is splitter. Next is mapper. Third is shuffler. Fourth is combiner. And the fifth is reducer. These are the 5 steps in a MapReduce program. Then how to identify the number of mappers created for a code? So you can just go to the config file and check, or the runner file that we were discussing, right? Just check. This one. So here in this configuration setting, you can check what is the number of mapper class you have set, and then you can get the number of mappers. Then what are the different ways in which you can write a code for implementing MapReduce architecture in Hadoop? So these different ways is nothing but this. Like you can write traditional Java MapReduce code, or you can write Pigleton, or you can write Hive, and then in turn that further drills down into a Java MapReduce code. So these are the 3 different ways that we have discussed to write a MapReduce code.